So I'm very pleased to present this French PENELOPE initiative on the behalf of the three co-leaders of the initiative, Dr. Emmanuel Kempf from APHP, Dr. Alain Livartowski from Curie Institute, and Professor Stéphane Darmony from the Rouen University Hospital. This initiative aims to improve cancer patient trial recruitment. So assessing patient eligibility for clinical trials is a very important challenge in the cancer domain in order to increase access, patient access to new therapies and to speed up patient inclusion and the start of the treatment. We face a double hurdle in EHR-based eligibility determination. We face first an interoperability challenge due to the lack of widely accepted standard representation for both eligibility criteria on one side and EHR data on the other side. And we also face a data quality challenge due to the poor quality of real-world data in electronic healthcare records. Cancers are complex diseases with complex treatments and complex patient trajectories. We make the hypothesis that the OMOP common data model and its oncology module could support the representation, the standardization of real-world data and its mapping to eligibility criteria. The cancer extension of the OMOP common data model provides a better representation of the natural history of cancers due to an episode-based extension, and also provides rules for deriving episodes from clinical events. And we also assume that focusing on a limited data set relevant for pre-screening process will support the hospital to address the data quality issues for that use case. So in this context, our objective is to evaluate the impact of the adoption of the OMOP oncology module on clinical trial eligibility pre-screening within a French network of university hospitals. So we will evaluate how far the OMOP oncology module efficiently supports the mapping between raw data and pre-screening clinical trial eligibility criteria. And we will also evaluate how far focusing on the minimum pre-screening data set and will support the hospital to ensure the quality of the data set. And the quality of the slides is not very ensured. Sorry for that. The initiative involves in the very first step of the project 2 hospitals that cared more than 200,000 patients for APHP and more than 230,000 patients for Curie Institute in the 5 past years. And in the first phase, the hospital will evaluate pre-screening module and the process based on queries executed using their proprietary existing querying tool installed on top of their own clinical data warehouse. And in the second phase, they will after having implemented the OMOP common data model with the cancer extension, they will re-execute the pre-screening queries, the pre-screening queries, and evaluate the performance of the pre-screening module and process and compare the performance to the performance observed in the first run. So I will give more detail on the different tasks. So the first task consists in defining a minimum data set and that is relevant for clinical trial eligibility pre-screening in the context of phase 2 to phase 4 cancer clinical trials. And then in the second task, the team translates the pre-screening eligibility criteria of a pre-selected test set of clinical trials into OMOP-based queries and assess the computability of the eligibility criteria. In the third task, the hospital evaluates the quality of the data of the pre-screening data set using their own tools. They evaluate the completeness, the conformance, and the plausibility, and they assess and they define a data quality plan in order to improve the current quality of the data in the scope of this data set. The first task is to implement the pre-screening module to execute the queries on their clinical data warehouse. And in the last task, they evaluate the performance of the pre-screening module against a gold standard consisting in the set of the already recruited or pre-screened patients. So, and as already mentioned, the second phase will consist in implementing the OMOP database with the oncology module in the 2 hospitals, and then to re-execute the pre-screening process and to compare the performance of the pre-screening module to the performance of the first execution of the pre-screening. So now the preliminary result that we have now related to the first task, the minimum data set relevant for the pre-screening has been defined. 2 experts in oncology, clinical research and drug development and IT system associated with 1 expert in data interoperability and 1 expert in data engineering have considered the existing model, the French Osiris model, a minimum set of 67 clinical and 65 omics item designed to accelerate data sharing in oncology. They also considered the MCODE data dictionary from a FIRE-based initiative and also, of course, the OMOP common data model. And they analyzed the eligibility criteria of 12 clinical trials. It results in a set of 360 eligibility criteria. And from this, 18% of this number of eligibility criteria have been considered as relevant for the pre-screening phase and have been standardized. That's the list of the information that was considered to be relevant in the phase of the pre-screening. This information is related to the patient or to the primary tumor, diagnosis, topography, morphology, stage, grade, biomarkers, also related to the tumor evolution, extent or dynamics, and also, of course, related to the treatment for each evolution. Sorry for that. I thought it was in PDF, but I am very sorry for that. But in the second task, the eligibility criteria has been transformed into OMOP-based pseudocode. And apart from a few remaining open issue related to the representation of the stage of the tumor or of the evaluation of the number of the metastatic sites, all the criteria could be translated into this pseudocode, and we assess the computability of the queries. The computability of the query depends, of course, on the expressiveness of the data model and of the query language, but of course it depends also on the availability and the quality of the data. I mean, it depends, and it has been just mentioned, on the quality of the ETL process developed to feed the model with real-world data, and it's not that simple, as you have all understood due to the previous talk. And as an example, in APHP, currently, only 35% of the concepts identified to be relevant in the pre-screening process are available in a structured format in the clinical data warehouse. So we are fighting to address this issue to be ready for a nice result in the second phase. And the fourth task is ongoing. So to conclude, the PENELOPE initiative promotes the use and the evaluation of an episode-based data model, the OMOP common data model and its oncology module. We also promote the verification of minimal data set of real-world standardized clinical and omics genomic items relevant in the specific context of the pre-screening process. And in fact, Curie Institute and APHP agree on using this common data model and on sharing the implementation guides that we will generate during phase 2 to accelerate the interoperability for trial eligibility at scale. And the two hospitals are also working on data quality control to be able to monitor the quality of this very limited data set dedicated to this use case. And so our perspective is to achieve phase 1 and phase 2, and we are also working at the design of phase 3, consisting in external validation of the pre-screening algorithm in other hospitals, not only in France. We are setting up collaboration with the University of Columbia in New York, which is, of course, really interested in the use, extended use of the OMOP common data model. And we are also setting up some collaboration with Harvard University and Duke University to evaluate how far the FHIR standard, FHIR API, and dedicated FHIR profiles could enhance the generalizability of pre-screening algorithm, not only within a network of hospitals having adopted an OMOP common data model. Thank you for your attention, and again, sorry for some issues in the slides.
Well done. Thank you very much, Christel. And indeed, we're sorry about the technical hiccups with the slides. That was not your fault. So we'll be able to take a few questions either from the audience or the chat online. Are there? Okay, we'll leave the audience gather the questions, but we can already start. So you mentioned FHIR and OMOP, but can you maybe explain why you have chosen OMOP to start with?
We have selected the OMOP because our interpretation now is that both standards are very interesting, very useful, but up to now, as far as I know, I think that FHIR is still too flexible with too much expressiveness, and I think the interest of the OMOP common data model, that could be also a weakness, but it is a strength until now, is that it is perhaps more constrained model, and that it's easier to achieve large-scale interoperability. It's our rationale until now. But in APHP, we are setting up an OMOP data model for reusing the data for research and innovation. And we have also on top our query engine, which is called 360 degree, is based on FHIR. So we go on thinking that it's interesting to work on parallel on OMOP and FHIR, and there are many initiatives aiming to map the two standards. Probably you would like to.
Yes, Peter Heinrich will elaborate
Yeah,
as
I'm happy
well.
to respond to that. Yeah, so there's actually a very close collaboration between FHIR and OMOP community. So there's an agreement and we work together to move this field forward. So it's really nice. I think it also serves two different types of purposes, OMOP and FHIR, which I think is a strength, not a weakness so much.
Would you like to comment on this? Or yeah.
No.
Okay, perfect.
Agree.
Thank you. You're in agreement. That's a good thing. Maybe one last question from the audience, or I will take one from here. Okay. Are there any work on transformation to OMOP format being carried out at the PHP? Yes,
for sure. This is a focus on a specific project dedicated to cancer and dedicated to the use case of pre-screening and patient eligibility. But in fact, we use the OMOP common data model to integrate all the data of the 39 hospitals in APHP, and it is used on a daily basis to build some cohort of hundreds of research projects. So